Hello and welcome. This is Cambridge O-Levels Additional Mathematics paper number 1. The subject code is 4037. This is May-June 2022 exam and this is variant 1 of the exam. So let's start. Question number 1, it says find constants A, B, C such that there is an under root P Q power 2 by 3 R power minus 3 divided by P Q power minus 1 whole square multiply by R power 1. And we have to simplify it in terms of P power A, Q power B, and R power C. And we have to find the values of these A, B, and C. So let's start solving it. So let's say this is your left-hand side of the equation and this is your right-hand side of the equation. So taking left-hand side. So we have P power 1 by P whole square is equal to, P power under root is actually P power 1 by 2. Then we have Q power 2 by 3. Then we have R power minus 3. Okay, and then we have P square below. So P square goes up, it becomes P power minus 2. We have Q raised to power minus 2 here. When it goes up, it becomes Q power 2. And we have R power minus 1. When it goes above the bar, it becomes R power 1. Okay. So now if we add the similar powers. So what are the similar powers here or similar entities? P, we are similar. So this becomes P raised to power 1 by 2. Add the powers minus 2. Okay. Then other than that, we have, say, Q power 2 by 3. This is 1 Q, this is 2. So add all the powers 2 by 3 plus 2. Then we have R. So we have R power minus 3, add all the powers plus 1. So simplifying it, what we are left with P raised to power minus 3 by 2, Q raised to power 8 by 3, and R raised to power minus 2. Now this is a simplified form, and if we compare it with P power A, Q power B, R power C, so we are left with A equals to minus 3 by 2, B is equal to 8 by 3, and C is equal to minus 2. This is our answer. Okay. So moving ahead, question number 2. It says a particle moves in a straight line such that its displacement s meters from a fixed point at time t seconds t greater than 0 is given by. So the displacement is given by s is equal to 1 plus 3t whole power minus 1 by 2. Part A, it says find exact speed of the particle when time t equals to 1. So remember, speed is equal to the first derivative of the displacement with respect to time. That is equal to ds by dt at time t equals to 1. If we find out this will give us the value or the speed of the particle at this time. So if we take the derivative, what we get, so let's say d by dt of 1 plus 3t power minus 1 by 2. Okay, so this becomes minus 3 by 2, 1 plus 3t minus 1 by 2 minus 1. Oh, sorry. Minus 1 by 2 multiply by this, multiply by the derivative of inside, that is 3. So this comes out to be minus 3 by 2, 1 plus 3t power minus 3 by 2. This is the derivative, or we call it as ds by dt. This is the derivative. Now the value of ds by dt at time t equals to 1. This comes out to be, just put 1 is instead of t and calculate. So this value, or this comes out to be minus 3 by 2, 4 power minus 3 by 2. If you calculate it, you can have, or because since this becomes 3 power 16, and remember the units are this displacement in meters. So this is in meters, and we are taking it time. So this would be meters per second. Units will be important as well. So this is the answer for this part. Okay, moving ahead. Part B, it says show that the acceleration of the particle will never be zero. So remember acceleration, we are given with displacement and displacement. And if we, this is displacement. We have also calculated speed, the first derivative, speed, or we also call it as velocity. And if we have to calculate the acceleration, we have to take the derivative of the speed or the double derivative of the displacement, and this comes out to be d2s by t square. Okay, so we have to find out the double derivative of this. So we have already found out the value of ds by dt. Let us call it as v. And this one was minus 3 by 2, 1 plus 3t power minus 3 by 2. Now, let's take dv by dt, the derivative of this, and this turns out to be d2s by dt square, and this turns out to be minus 3 by 2 multiplied by minus 3 by 2, 1 plus 3t power minus 3 by 2 minus 1 multiplied by 3. Okay, so this value, and then let's call it as a, and this value of a acceleration comes out to be 9 into 3, 27 by 4, 1 plus 3t power minus 5 by 2. Okay, so this is my acceleration. And the thing, and we have to show that this will never be zero. So let's try to find out. So what will happen? So or the good check is to find value of t when a is equal to 0. This makes us do is 2 by 4, 1 plus 3t minus 5 by 2, and make this thing equal to 0. Okay, so what we get 1 plus 3t power minus 5 by 2 is equal to 0. And remember, if we are going to solve this, this will no such value of t exists. Okay, so basically this thing will not exist, or you can say that a is equal to 27 by 4, 1 plus 3t power minus 5 by 2 will always be positive for all values of t. So this is how you're going to write this answer. Okay. So moving ahead, question number 3, it says a function f is such that f of x is equal to natural log of 2x plus 1 for all values of x, or for x greater than minus 1 by 2. Part A, it says write down the range of values of x. So the range. In this case, remember the range of x, f of x, or if my value of x is, so say if I have this line, this is my x, this is my 0, and let's just say 1/2, this is 1, and it goes on and it goes on till infinity. So what I can do is, for all values, this function f of x can be done for all values of x that belongs in this region. Okay, you can take any value of x that is greater than 1.2, all values of x that lie in this region. So, and that will be giving us the value of f of x. And what the value be? It can be any real number in this line, in this side. So f of x belongs to a set of real numbers. Okay, and this will be your answer. Okay, so moving ahead, part B, it says a function g is such that g of x 5x minus 7 for all x belongs to real number, or the set of real numbers. It says find exact solution of g of f of x. Okay, when find exact solution of equation g of f of x is equal to 30. So remember, f of x was natural log of 2x plus 1 for all x greater than 1/2. Okay, so f of g of x. So what we'll be going to do, we have g of x is equal to 5x minus 7. Instead of x, we put f of x. So it becomes 5 of f of x minus 7. And so this becomes g of f of x. And this becomes 5 of natural log of 2x minus 1, 2x plus 1 minus 7. So if we simplify it, it becomes 5 natural log of 2x plus 1 minus 7. And this value is given to us is equal to 13. This value is equal to 13. So now if we equate it, so it becomes 20. This 7 goes here. 25 natural log of 2x plus 1. This becomes natural log of 2x plus 1 equals to 4. If we remove the log, it becomes e power 4, 2x plus 1. So it becomes x is equal to e power 4 minus 1 divided by 2. So this is the value of, or the exact solution of, the equation g of f of x is equal to 13. Okay. So moving ahead, part C, it says find solution of the equation f or f dash x g of is equal to g inverse of x. Okay. So how or how to solve it? First of all, we find f dash of x. So this is the first derivative, or we have to find out d by dx of f of x. This is the first derivative of f of x. And this is equal to d by dx natural log of 2x plus 1. This comes out to be f dash x equal to 1 by 2x plus 1 multiplied by 2. This is 2 over 2x plus 1. So this is f dash of x for the first derivative of x. Let's highlight it. Then we have to find out g inverse of x. So for g inverse of x, let's say let y is equal to, remember g of x was equal to, remember g of x was equal to 5x minus 7. So 5, this becomes equal to 5x minus 7. So make x as subject. So when we are going to make x as subject, becomes 7y plus 7 divided by 5, and this becomes equal to x. So if x is this, so what becomes? So G inverse of x is equal to uh, x plus 7 plus 5. So, or you can call it as y as G inverse of x. So eventually, G inverse of x becomes equal to this. Okay. So G inverse of x is this. So what we are given? We are given that f first derivative of x is equal to G inverse of x. So we are going to derivate to 2x plus 1 is equal to x plus 7 divided by 5. So solving this, we become 10 equals to 2x plus 1 multiplied by x plus 7. This equals out to be 2x squared plus 14x plus 7. 2x squared plus 14x plus x plus 7. And eventually what we get is, so if you are going to simplify it, so becomes 2x squared plus 15x minus 3 equals to 0. So now this is a quadratic equation. This is a quadratic equation. So using x equals to minus b plus minus under root b squared minus 4ac over 2a. So now put in the values. We have a is equal to 2, b is equal to 15, c equals to minus 3. Now if we put these values, what we get? We get two roots. X1 is equal to 0.195 and x2 as minus 7.695. So these are the two roots of the equation. But remember, there is a catch here. We have to mention the answer. So f dash of x, so f of x, remember, f of x was for all x greater than 1 by 2, and g of x was for all x belongs to real number. So any of value of x that lies in this ballpark will be the one we are looking for. So, and since we are taking the inverse of x, this range will be inward. Yeah. So no, forget about the range. So anything that falls in this criteria will be the one we'll be using. So answer, this one will be the one we'll be using. So, so this value will be rejected. Okay, so this one will be our answer. Okay, so this is how we solve this question. So moving ahead, question number 4. Question number 4, it says that the diagram shows graph of y of f of x, whole modulus, where f of x is cubic function. Find the possible expressions of f of x. So f of x is equal to y, and we see that on the x we have solution. So y is x minus 1 is one solution, because we have x is equal to 1. We have x equals to 3, another solution. We have x equals to minus 2. So from these 3 points, so x equals to 1, we can have x minus 1 equals to 0. This is one solution. This is x equals to 3. We can have x minus 3 as one solution. This is one solution. This is one solution, and we have x equals to -2. So x plus 2 is another solution. So these are the possible three values that can give us the solution. So find possible expressions for f of x. So f of x can be you can say any x plus 2 multiply by 3, or multiply x minus 3 multiply by x minus 1. Okay, this is one value. We also can see that for x equals to 0, when we have x equals to 0, we have y is equal to 24. Okay, so we have this value as well. So we have to basically incorporate this value in the solution. So we can write this, but this thing will you can say not be any exact value. There would be some sort of multiple that will be coming here. So let's see what we can also infer from this. So when x is equal to 0, so if we say 0, 0, so we have 3 into 2 minus 6. So in this function, if we put x equals to 0, the f of x value will be -1 multiplied by -3 will be equal to 2 multiplied by -3 multiplied by -1, and this will be equal to 6. And actually, what from the graph, what we'll be having, we need a value of 24. So we need to multiply it with 4. So we need to multiply it by 4. Okay. So this is how it should be written. So the answer, and since this is a modulus function, so it means that it can be +4 and it can be -4. So the possible expression can be this, or -4 x plus 2 x minus 3 x minus 1. Okay, this is 1, and this 4 can be multiple with any of these three values inside. You can say f of x is equal to x plus 2, and then multiply 4 by, so 4x minus 12 x minus 1. This can be one. Another f of x can be multiply 4 with the first one, 4x plus 8 into x minus 3 into x minus 1. So you can easily write other options, multiply 4 with them, or you can do 2 multiply by 4 can be written as 2 multiply by 2. So you can multiply 2 with one of the factors and 2 with another factor. You can generate lots and lots of functions. So it says possible combination. So just write 2 or 3 possible combinations of this, and you will be fine with the answer. So moving ahead, part B. Part B, it says on the axis below, sketch the graph of y is equal to 2x plus 1 and the graph of y is equal to 4x. Y is equal to 4 multiplied by in brackets x minus 1. And remember, both of these are in mod. So your graph will, the output value of f cannot go in the negative domain. The value of f is always in positive. So the best way is, so draw a graph of y is equal to 2x plus 1. So how this graph would look like? So at x equals to 0, your y is equal to 1. So when this is here, your y value is 1. Say this is 2, this is 3, this is 4. So x equals to 0, your y value is 1. So 1 of, and when your y value is 0, your x is equal to -1 by 2. So x is equal to -1 by 2. So say this is my 1, this is my 2, 3, 4, 1, 2, 3, 4 again. 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4. So the value of this will be somewhere here. So if I draw a straight line, it would look something like this. So this is y is equal to 2x plus 1. But if we have to take mod, whatever goes below x-axis will be reflected. So just reflect this line. So this one will be, or my graph will look something like this. So I'm drawing it with a dark green line. This is one line. Oh, remove it. So this is my other line. So this is the graph of y is equal to x plus 1. Similarly, for y is equal to mod of 4 into x minus 1. First of all, draw a graph of y equals to 4x minus 4. So case 1, when x equals to 0, your y value is x equals to 0, y value is minus 4. So when x is equal to 0, your y value is somewhere here. Okay. And when your y is equal to 0, your x value is somewhere, your x value is 1. When y is equal to 0, your x value is 1. What is happening? So that this graph is a straight line like this. This graph is a straight line like this. Okay, and you have to reflect this straight line back up, so it goes something like this. Okay, so let me draw it by, I will remove this line and let me draw it by dark blue line. So let's see, this is one of my line and this is my other line. Okay, so I mean, you can always draw better than this because I don't have a ruler over here, so I apologize for that. So this is how your graph. So, and again, it says stating coordinates of the points where the graph meet the coordinates. Okay, so this point is on the x, it is 1 by 2 minus 1 by 2, y is 0. This is one coordinate. This is x equals to 1, y equals to 0, second coordinate. This point is x equals to 0, y is equal to 1. This point is x equals to 0, y equals to 4. Other coordinates, so your both graphs intersect at this point. So this point is will actually be, and you can find out from the equation, and also your graphs will be intersecting somewhere here. But since they are not, we are not asked about these points, so it's not recommended. We're just stating the coordinates of the points where the graph meets the coordinate axis. So one point, call it A, call it B, this call it C, call it D. The point A, B, C, D. For point A, you have 0, 4. For point B, you have 0, 1. For point C, you have 1, 0. For point D, you have minus 2, 0. Okay. So this is how, or these are the 4 coordinate points which you have to mention to get complete credit for your answer. Okay. So moving ahead in part 2, it says find the exact solutions of the equation. Basically, now you are solving f of x. Oh, not f of x. Y, both equations of y. Basically, this is the equation where your graph intersects. Graph intersects. Okay. So you can also use your graph to find out the value, but you have to find out the exact solution. So remember, this is not f of x. So exact solution, 2x plus 1 is equal to 4x minus 4. Solve it for x. So what we are left? We are left with minus 2x equals to minus 5. So x is equal to 5 by 2. So this is, you can call it as case 1. Okay. The second case, case 2. Remember, we can always, so this is case 1. So this is the positive side of the graph intersects with the reflected side, and here the positive side reflects with the uh, uh, again the reflected side. So the other case would be 2x plus 1, and add the modulus sign, it would be minus 4x minus 4. So this will be 2x plus 1 minus 4x plus 4. So x will be 1 by 2. Okay. So these are the 2 points, and we can see here from the graph that these are the 2 possible solutions, right? So these are the 2 possible solutions from the graph which we are getting. So the solutions are, so x equals to, so solutions are x equals to 1 by 2, y is equal to 5 by 2. Okay. And this is my answer. Okay. So the easiest thing to, or easiest way to solve it is, so just when you remove the mod, you do this equals to plus minus 4x minus 1. Just do with any one of this, although it also gets plus minus, but it's always good to use it with 1. So just have plus minus. So solve it when you have with plus, you have one equation. Solve it with minus sign, you have another equation. You'll get your 2 values that will be there. Okay. So then next part, moving ahead, part B, it says find a vector which is in opposite direction to 15 by 8 and has a magnitude of this. So let us say we are given a vector A. This is, and it is 15 comma minus 8. Okay. And the magnitude of A is 8.5. Oh no, sorry, it is opposite to the direction. Let A vector is this. And we have to find out a vector. Let's say, let's call it as vector V, which is opposite of A. So what we have to do, we have to find A, or unit vector of A. Unit vector of A. So unit vector of A is A hat, that is equal to A vector divided by A magnitude. So magnitude of A will be, or the magnitude of A will be 15 square plus 8 square whole under root. So this magnitude comes out to be 17. So my unit vector is 1 by 17, 15 minus 8. This is my unit vector. And now we have to find opposite, opposite in direction of A. It means that it should be in the direction of minus A hat. So A unit vector is the direction vector, or the opposite in the direction of A vector is equal to minus A hat with a magnitude of 8.5. It means that you multiply 8.5 with minus A hat. So your output vector will be my 8.5 with a minus sign, multiply by A hat, which comes out to be 1 by 17, 15 minus 8. So if you simplify it, it comes out to be 8.5 minus 8.5 is actually 17 by 2. So it comes out to be 17 by 2 multiply by 1 by 17 multiply minus sign inside. Okay, so 17 cancel. So this vector v is equal to 1 by 2 minus 15 and 8. This is a vector that is in opposite direction of the given vector 15 and a minus 8, and the magnitude of this vector is will be equal to minus, it will be equal to 8.5. So next part B, it says find the values of a and b such that 5 times 3 times 3 by a plus another b. So this is actually a addition of two different vectors and sum or simple parallelogram law. So these just compare the top or make this case as two simultaneous equation. So first case will be or simplify it is like this: 15a 5b plus 2a plus 1 2 6b plus 6a 12. Okay, make two equations and solve them simultaneously. Okay, so we make two equations: 15a plus 2a plus 1 equals to 6b plus 6a. Simplify it, I get this is my first equation. So if I simplify it, I will get 11a minus 6b equals to minus 1. So this is my first equation. Second equation will be 5b plus 2 is equal to 12. This gives me b is equal to 2. This is my second equation. So put 2 in 1, we get, so it becomes 11a minus 6 into 2 equals to minus 1. So a becomes equal to 1. Okay, so a becomes equal to 1. So now, so values of a is equal to 1 and b is equal to 2, and this is your answer. Okay, this is how you solve this question.